Welcome back to All This Math. This is Professor Parker. Make sure you are subscribed to the All This Math YouTube channel. And please like and share the video. Now, I got my Howard University Africana Studies Department 50th anniversary sweatshirt on. I didn't attend Howard University, but I support all HBCUs. And I know a lot of solid people that did attend Howard University. Also want to give a shout out to the ancestor, the late Dr. Nathan Hare, his wife Julia Hare as well, who also was a scholar. They worked together, but Nathan Hare was instrumental in a lot of the work that was being done in the late 1960s, which led to there being an Africana Studies Department or a Black Studies Department established at Howard University back in the day. There's like a timeline on the back of my sweatshirt. I don't know if you can see that, but yeah, but do your research. Do your research on that. Um, let's get into this. So today I wanted to talk about some everyday algebra, right? What do I mean by everyday algebra? I mean when we use the everyday common parlance, the vernacular, the slang that we might use, and how that reflects algebra, right? It reflects algebra. So let's say if you're in college, you're taking a college algebra course. Or let's say you're in high school and you're taking an algebra 2 course or a pre-calculus course, or maybe even in an algebra 1 course, right? You might see an expression that looks like this. Well, this is called an inequality, right? Not an equation, but an inequality. This reads x is less than or equal to 15, right? So that means all the values in the solution set, right, in the large group of solutions are going to be either they could be 15. One of the solutions could be 15 because it's equal to 15, but also less than 15. So 14 could be a solution. 14.5 could be a solution. 10 could be a solution. 1 could be a solution. 0 could be a solution. Negative 89 million could be a solution. Any number that is less than 15 or is 15 could be a solution, right? Another way we show that is what's called interval notation. Interval notation, right? So this information can also be represented this way. This is called set builder notation, right? I'm pretty sure set builder notation. I always forget what this arrangement is called, but I believe it's set builder notation. But I did leave out some of the details because you're supposed to put like an X and then a colon or X and then a long vertical bar and then But this is basically the gist of what it is trying to communicate. X is less than or equal to 15. But over here, this is interval notation, which shows the interval on which the solutions are. So this symbol is infinity, and that's a negative sign. So that's negative infinity. So that means all the solutions from negative infinity, and infinity is not an actual number, but it's more of an idea of a quantity, right? From negative infinity all the way up to positive 15. Now notice how there's a parentheses right here, and there's a bracket right there. Parentheses, bracket, parentheses, bracket. Now you put a parentheses next to the number if that number is not included in the interval, right? If it's not included in the interval, right? Now infinity is not an actual number, so infinity can't never be included in the interval, whether it's positive infinity or negative infinity. It can't never be included. So infinity or negative infinity will always have a parentheses next to it, always in interval notation. Over here, this has a bracket because 15 is included. So all the numbers that are less than 15 are in the solution set, but 15 itself is also one of the solutions, right? So that's why there's a bracket next to the 15 to indicate that 15 is included. So if you was graphing this on a somewhere if this was a curve or this was a straight line, then you would put a point, a shaded in point at 15, right? That would be one of your values. All right, now why do I have this written right here, doing the most? Why do I have this written right here, doing too much? A lot of times people get accused of doing the most or doing too much. I want to show you how that's relevant to this. If you're doing the most, that's like considered to be like the maximum amount possible allowable in that given situation. So according to these setups or these representations of intervals of solutions, right, of possibilities, right, of what is it parameters, right, within which we can fall, doing the most would be at level 15. We're at 15, right, because that's the most, right, in this interval from x, because x is less than or equal to 15. So if your level of whatever you was doing is like at 10 or 9 or something, then you probably chilling. Like nobody probably would raise an eyebrow, look at you no type of way, because it's like, all right, you in a decent range, right, of activity. You're in a decent range of activity, right? you're not getting on nobody's nerves. But when somebody accuses you of like doing the most, it's like, yo, you at 15, man. You doing the most that's allowable, right? So if X is less than or equal to 15, 15 is the max. Doing the most means that's what you're doing, right? You're doing the most, you're doing the maximum, right? Also here is represented here. Interval notation, set builder notation. You at 15, you're doing the most. Now, if you're doing too much, now that would probably mean that you off the parameters. So you might be at like 18 or 19. That's too much, right? That's too much because that's not even within the solution set. Like you out of pocket, right? You really out of pocket, right? And as a matter of fact, you can consider this as a pocket. This interval right here, I ain't even thinking that. That's off the top just now, right? So this could be considered like a pocket, right? So if you out of pocket, that means you're outside of these parameters, outside of the solution to the algebraic expression or the algebraic equation or inequality in this case, right? So doing too much means you're going beyond the interval. You outside the interval, right? You're doing more than the maximum value in the interval. All right. So that means you at like 15.1, 16, 17, 28, 35, 98, 153, 2,371.68. All those numbers are larger than 15. You're doing too much. You're doing too much. Now, if you're doing the most, the way I interpret that is you're within the parameters, but you all the way at 15. You don't gotta be at 15. Maybe in that given situation, it's appropriate for you to be at like a 1 or a 3 or even a 7.9, something like that. Maybe you don't need to be at 15 doing the most, right? The most is the maximum. So I wanted to talk about this because a lot of times we talk about how math is irrelevant and math is unnecessary and algebra is irrelevant. I'm never going to use this in life. But I want some people to understand you already using it. You just might not even dig it. You already using it for real. You already using it. When you say you're doing the most, that's a mathematical expression. When you tell somebody they're doing too much, or you say, well, I don't want to do too much, or I don't want to do the most, right? That's mathematical language. You got to understand that. That is mathematical language, you know? So we got to understand how math is all around us. Math is already integrated into our everyday lives. We got to stop running away from it because it's just a lot of cat, right? For us that we've been sold to get us thinking that math is irrelevant, math is too difficult, math is not going to help us in any way. And what that does is it allows you to disqualify yourselves from competition in certain fields, especially STEM disciplines, right? Science, technology, engineering, mathematics, those type of disciplines. It allows you to self-disqualify yourself, right? So that you can't compete with those that are not being told about the irrelevance of mathematics or that they're not intelligent enough to do mathematics, right? So you gotta stop falling for that, right? Also, math is about problem solving. Math is about critical thinking. And every responsible human being needs to be able to problem solve and needs to be able to think critically and also reason analytically as well. So three things, right? So when you say no to math, you're saying no to problem solving, you're saying no to critical thinking, and you're saying no to analytical reasoning, which are three things that I'm sure you can agree are relevant and important. So there's a lot more examples like this I'm gonna get into on this channel or maybe on social media, on TikTok or on Instagram as well. You know, maybe I'll do some reels or something. But yeah, it's a lot of examples, and I'll be thinking of these all the time. And I think actually I might have made I made some videos on this channel already, like in the past, that are basically reflective of this type of thought process. How we can take, idioms or I don't even is this an idiom? I don't know. Different vernacular, different slang terminology, and how they can be represented mathematically. All right. So just something I want y'all to think about. All right. And shout out to Howard University. This is their homecoming weekend. I'm not going to be there. I'm going to be down at GHO. North Carolina A&T's homecoming. Homecoming's on the same weekend. So that's where I'm going to be at. But definitely shout out to Howard University. Peace.